Hello viewers, welcome to my YouTube channel Chem Corona. In last video we have discussed non-steroidal anti-inflammatory drugs. So I welcome you again to the part 2 of this video. We are going to discuss the further classes of NSAIDs. Under that, the first class we are going to discuss is aryl acetic acid derivatives. Example is indomethacin. Indomethacin was synthesized in 1961 at Merck as a part of the study of indole derivatives as potential anti-inflammatory agents. Since serotonin contains indole nucleus and is a potential mediator of inflammation, they thought to test this drug indomethacin for anti-inflammatory activity. The structure of indomethacin is represented below. It contains para-chlorobenzoyl group as well as indole 3 acetic acid and a methoxy group at 5th position. There are two different conformers of indomethacin. We can see they are given here. So, which one is the correct conformer? So, the one which is indicated in red ring is the correct conformer of indomethacin because we can see here the methoxy group and the para-chlorobenzoyl group. They lie in same plane. So, that's why that is the correct conformer. Let us discuss the SAR of indomethacin. If we replace the COH group with other acidic functionalities, there is decrease in the activity. If acidity of COH is decreased, there is decrease in anti-inflammatory action and vice versa. Amide analogues are inactive. The N-benzoyl derivative substituted in para position with fluorine, chlorine, thiomethyl, trifluoromethyl is found to be most active. Fifth position of indole ring contains methoxy, fluoro, dimethylamino, acetyl or methyl are more active than unsubstituted indole rings. The CH3 at alpha position is more active than aryl substituents. S-enantiomer of indomethacin is more active. Indole ring nitrogen, it is not essential for activity that is indicated in sulindac. We can see here, this is the structure of sulindac. In indomethacin, there is presence of 2 nitrogen in the indole ring, whereas in sulindac, there is presence of only 1 nitrogen atom. Thus, the heterocyclic nitrogen was removed and a double was introduced in sulindac to give indene derivative. The Z isomer is more active of sulindac than the E isomer. Isosteric replacement of indole ring with indene ring, this is indene ring, gives less GI side effects. Introduction of fluoro group at 5th position increases the analgesic activity. Introduction of methyl sulfonyl increases the solubility while retaining the potency. Replacement of para-chlorobenzoyl substituent with benzylidene function gave active derivatives. The next class is aryl and heteroaryl propionic acid derivative. Example is ibuprofen, flurbiprofen and ketoprofen. Ibuprofen is the prototype drug of this class whose S isomer is active. In flurbiprofen, there is presence of 3-fluoro substituent which ensures the non-coplanarity, whereas in ketoprofen, the advantage of this drug is that it inhibits leukotriene pathway. Other drugs of this category include suprofen, phenoprofen and ketorolac. Suprofen is an isoster of ketoprofen. It contains a thiophene group. Phenoprofen is less potent than many of the others for inflammation with some analgesic and antipyretic activity. Ketorolac has a pyrrole ring but is a cyclic propionic acid derivative. Then we also have naproxen, carprofen, and oxaprozine. Naproxen, it contains a second additional non-coplanar ring. It is optically pure and the S isomer is having more activity than the R isomer. Carprofen is used for veterinary purposes and oxaprozine is an aryl propionic acid, but it is unique in that there is propyl ring is not branched. Further, we have the other class, that is Oxicams. Example is piroxicam and meloxicam. Pfizer developed this class to produce non-carboxylic acid NSAIDs. Piroxicam is the first member of this class. The enolic hydroxyl is the acidic group. Pyridyl ring is the second aromatic ring which is present in this class of drugs. Meloxicam, it is found to have COX-2 inhibitor activity, but it is not COX-2 inhibitor. SAR of Oxicam includes active analogues have CH3 group on the nitrogen and electron withdrawing group on the anilide phenyl. The N-heterocyclic carboxamides are more acidic than the N-aryl carboxamides. If we interchange the benzene ring with thiophene, we get a new class of drug, that is tenoxifam, and it is found to be active. Miscellaneous drug, it includes etodolac, nabumutone. Etodolac is considered as a non-classical bioisoster of aryl propionic acids. It has much better GI profile than aspirin. Nabumutone is a ketone and thus non-acidic, and it is classed as an alkanone. It is a prodrug and must be activated by beta oxidation to give 6-methoxy 2-naphthyl acetic acid. The last class is COX-2 inhibitors. Now, these drugs, they selectively inhibited cyclooxygenase 2 enzyme. So that's why they are called as COX-2 inhibitor. Examples include celecoxib, rofecoxib, and valdecoxib. Celecoxib was the first drug of this category. It contains pyrazole ring. Structurally, it differs from other NSAIDs in that it is weakly acidic. Rofecoxib is not acidic, but it contains furanone ring. You can see here there is presence of furanone ring in rofecoxib, whereas valdecoxib, it contains isoxazole ring. It is a sulfamyl and its package insert contains the same caution. It is this phenyl group which is inserted into the extra space in the COX-2. Thank you for patient listening and happy learning. Subscribe, like and share my channel, that is Chem Corona.